So the last thing that I just said was that the degree, this highest power, tells you the maximum number of zeros that your polynomial is going to have. So this will have at most 3, but it could have less than 3. And these are called repeated zeros. Sometimes they're said that they have a multiplicity of a certain amount. So let's graph that, and I can show you what they look like on a graph. So x cubed, y equals x cubed. So again, if I was there, we'd be using graphing calculators for this. Hopefully you're practicing using your graphing calculator to graph it. X squared minus 16x plus 20. And I'm pretty sure that's, let me check. Yep. All right, so I'm going to graph this, get a picture of it. And here is what I want you to notice on the graph. So it looks like here at -5, that's possibly one of our zeros. And then notice here at 2, it comes down and it just barely kisses 2 and then goes back up. As far as we can see, that's what it does. Sorry. As far as we can see, that's what it does. So if it doesn't like pass through it and go down, switch from positive to negative, if it just touches it, that's a repeated root. So it looks like the zeros here are 2 and 2. It's 2 itself twice and -5. So I have some potential that I'll check. I think it could be 2 and -5, and I think that this one is repeated. And so if it is repeated, that actually, okay. Let's try that too. So what I'm saying is x minus 2, notice that's what gives me a 0. X minus 2 is a root for that. And if it's repeated, it's going to happen twice. So let me divide x minus 2 from this twice. And what I'll do is that synthetic division. So I use the root, right? I don't use -2. I use the root for synthetic division to do this division. I have 1x cubed, 1x squared, -16x's and 21's. So bring it down, multiply. Add, multiply, add, multiply. Yeah, so that's true. So notice then that I have I factored out an x minus 2, and what's left is x squared plus 3x minus 10. Remember, this was a cubic. I divided it, so it's now a square. And I could just like use quadratic formula here to get there, but I'll just try this other two using synthetic division. And what's nice about repeated synthetic division is I can just work off my own work. Bring down the 1, multiply 2 times 2, add 5, multiply -10, 0. Absolutely. So I have x minus 2. I took out another x minus 2. And look what's left, x plus 5. And that would have given me that other root. So this factors to x minus 2 times x minus 2 times x plus 5, but my zeros are just 2 and -5. If you want to write the 2 twice, that's not a problem. It has a multiplicity of 2. I'm not going to test you on that. But that's how we talk about a repeated root. It could happen 4 times. It would have a multiplicity of 4. That sort of thing. Okay, so knowing that helps us a lot. There's one other thing, another tool that I want to give you. It's called the rational zeros theorem. And it's pretty notation heavy in your book. It basically says if you have a polynomial of this form, a sub n of x to the n plus a sub n minus 1, x to the n minus 1 plus, boom, 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 keeps going on, a sub n of x plus a sub 0. What it says is if you have a 0, if p over q is a 0, then p, the numerator, the top, has to be a factor of the last term of a sub 0, and q has to be a factor of the leading coefficient of a sub n. So what that does is that actually gives us a list of all possible factors, all possible zeros for any polynomial. So like if I look at this one, notice my last term's 20 and my first term is 1x cubed. So basically I have all my potential zeros are the factors, whoa, I don't know what happened there, are the factors of 20 over the factors of 1. Notice it's the last over the first. And factors of 20, yeah, sure. Plus or minus 1, plus or minus 2, plus or minus 5. Forgot 4. Plus or minus 4, plus or minus 10. And those would all be over 1. Notice negative 5 is one of them and 2 is one of them. And we could go back to work that we've done and check that as well. Notice this one, the back number's 12, the top number's the front number is 1. So factors of 12 over factors of 1, that would give us plus or minus 1, 2, 3, 4, 6, and 12, all over plus or minus 1, 2, and 3. Boom. Those were there. These don't fall in because they're not rational. They're imaginary. So that actually helps us a lot. That helps us find another way for us to find factors or find zeros. So let's think about if we had like y equals 6x cubed minus 5x squared minus 7x plus 4. We've got to find all the zeros on that. So first off, what are all my potential zeros? They'd be the factors of 4 over the factors of 6. So it's not really 4 over 6. It's all the factors of 4, which would be plus or minus 1, plus or minus 2, plus or minus 4, over all the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. A lot of possibilities, but those are my only potentials. So then what that can help me do then is maybe interpret my graph. If I were to graph this thing, let's see, what was it? 6x cubed minus 5x squared minus 7x plus 4. And I'll graph it. Looks like I might have one here at -1. This one looks like it's around 1/2. This one looks like it's, I don't know, somewhere between 1 and 1/2. But I have this -1. That's a pretty good potential I can pick away at. That's a possibility. Notice 1/2's a possibility. Let's see. 4/3. That might have been like 4/3. It might be about 1 1/3. Well, let's check it out. Let's see what happens. But really, -1 is going to be my easiest one to check. So that would come from x plus 1. So what I'm going to do now is going to pick away and find these zeros. So x plus 1, I'm going to divide this thing by x plus 1. And remember, I can do it with long division, but if I do synthetic division, I use the root. And those coefficients, I have 6x cubed, -5x squareds, -7x's, 4 1s. Bring it down, multiply. Add, multiply, add, multiply, nice. 0. So I divided this by x plus 1. It is a 0. And notice what's left is a quadratic. 6x squared minus 11x plus 4. And now I can work to factor that. I can use quadratic formula. I'm going to grab my calculator, use quadratic formula. Oops. So A is 6, B is -11, C is 4. And what I get is 1/2. Nice. And 4/3. Great. So my zeros on this are -1, 1/2. That should be a 3. I said 4/3. And 4/3. And what that would mean, if I had to factor this, it factors to x plus 1. And if I think about this 1/2 would come from 2x minus 1. Right? And then 4/3 would come from 3x minus 4. But I was just looking for the zeros. Let me do one more like this. And then I'm going to have you do one. So I want to find all the zeros of 6x to the 4th plus 7x cubed minus 12x squared minus 3x plus 2. Boy, I really drew that poorly. I'm sorry. I'll fix that minus sign. That might be better. I don't know. So I need to find all the zeros of this. So potential zeros would be factors of the back over factors of the front. So it could be plus or minus 1, plus or minus 2, over plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So it could be 1, it could be 2, positive those. It could be 1/3, 2/3. You know, I have a couple different possibilities. So let me see if I can't get a little decent graph of it. So it was 6x to the 4th, not to the 34th, to the 4th, plus 7x cubed minus 12x squared minus 3x plus 2. You could do this on your graphing calculator. Get some decent shape for this thing. Yeah, so let's see. There's 4 of them. Looks like there's one here at -2. Looks like there's one here at 1. And those were both good ones. -2 and 1. And then there's some fractional ones. Maybe -1/2. Maybe 2/3. We'll see. So let's deal with these. If these are possible roots, remember these would come from x plus 2, and this one would come from x minus 1. So I'm going to do these divisions. I'm going to get these out of here. So I'm going to divide this by x minus 2, use synthetic division, so I use the root. And then these coefficients, 6x to the 4th, 7x cubes, -12x squareds, -3x's, and a 2. Okay. Synthetic division, the 6 comes down, multiply, -12, and I add, what's that, 4? Sorry, I just zoned out for a second. That's a 5, -5. -2 times -5 is +10. That adds to a -2. -2 times -2 is 4. That adds to a +1. 1 times -2 is -2. Great. That gives us a 0. So -2 is a 0. Right. That's my goal, to find the zeros. One of them's -2. So far what I've done is I've divided out this x plus 2. And what's left then is this. That was a 4th power, so a cubic. 6x cubed minus 5x squared minus 2x plus 1. And I'll keep going. That was 1. I'll see if 1 was a root. See if this x minus 1 goes into it. And again, I don't need to rewrite it. I can just keep going from here. Bring it down, multiply, add, multiply, add, multiply. Yes. Another 0. Very good. So yeah, it looks like 1 is also a 0. What I've done then is I've factored out the x plus 2. I've factored out the x minus 1 from this. And that's what's left is 6x squared plus 1x. I didn't need to write the 1. Minus 1. And then now I have this quadratic. You know, what I could do with the quadratic is I could use quadratic formula. I could just use quadratic formula. I could try and factor it. Both of those will work. And when I use quadratic formula on my calculator, I get -1/2 and 1/3. So great. That gives me my other 2 zeros, which would be -1/2 and 1/3. If I had to factor it, it would be x plus 2 times x minus 1. And then if I were to factor this, I would get 2x plus 1, opposite sign, 2x plus 1, opposite sign. So 3x minus 1. All right, so you have some tools. You have this rational zeros test that gives you possible zeros. You have a graphing calculator. I have Wolfram Alpha, but you have a graphing calculator, so you can get a graph and get an eyeball form. And you have synthetic division, which you can whittle down to a quadratic and then use your quadratic tools. So you've seen me do a couple. What I'd like you to do now is find all the zeros for this. X cubed minus x squared minus 10x minus 8. So find all the zeros for that, talk about it, and then I'll show you a solution.